Hello guys, this is a video, the first video where I'm going to show you how to work with the functions and find the stationary points, maximum and minimums, and points of inflection, okay? So this is the function, it's a cubic function. First of all, we have to find the stationary points and we need to determine their nature, meaning that maximums or minimums or possible points of inflection. So first thing we're going to do is to calculate the derivative. We know that the condition for a stationary point is that the derivative, first derivative is 0. So 3x squared plus 6x minus 9 has to be 0. Okay? I am going to take 3 as a common factor for easier calculations. Minus 3. Okay? This is equals to 0. Well, once I have this, I will keep on factorizing to state the stationary points better. I know that this is a quadratic, therefore I need two numbers, which multiplication is minus 3 and their addition is 2. So to get an addition of 2 and the multiplication of negative 3, we need to have x plus addition negative 3, right? Multiplication negative 3 plus 3 times x minus 1. Okay? Because if we add 3 plus negative 1, we get 2, and if we multiply them, we get negative 3. So this way is very easy to find the stationary points. They are going to be x equal negative 3 and x equals 1. So in the number line, I am going to plot 1 here, 0 here, and 3 more or less here. Okay? So in these points, the derivative is 0. Okay? Derivative equals to 0. First derivative is 0. Sorry, I am going to write it on a side. First derivative is 0 here and here. Zero, this is the one. Okay, here we are. Well, now I am going to state what happens both sides of these numbers. So, for example, if I am, negative 3. Yeah. So if I am in negative 3, for values which are lower than negative 3, this the first bracket is going to be negative and the second bracket is going to be negative, so the derivative is going to be also negative. Sorry, positive, negative, negative, positive. Then a number in between negative 3 and 0, very close to negative 3 but bigger than negative 3, so in absolute value lower, so the first bracket is going to be positive and the second bracket is going to be negative, since the number we have to pick is still negative. So positive, positive, negative, this is going to be negative. Therefore, if we have an increasing function on the left and a decreasing function on the right, in this point x equals to negative 3, we're going to have a maximum. Let's go now to find the value of the first derivative in the at the left of 1. So if it's left to 1, it's going to be from 0 to 1. So if it's from 0 to 1, the second bracket is going to be negative, the first bracket is going to be positive, and this and multiplied by 3 is going to keep on being negative. On the other side, if we take any number positive bigger than 1, then both brackets are going to be positive, with the 3 which is also positive, the derivative is going to be positive. If on the left we have a decreasing function and on the right we have an increasing function, this is going to be a minimum. Therefore here we have this. We have the situation where we have a maximum in x equals to negative 3 and a minimum in x equals to 1. I am going to continue in another video.